Hi, this is Mr. Gilman, and today we're going to solve linear systems by substitution. So, basically, here's what we're going to do. We're going to be given a system of equations, so two equations today, and we're going to solve one of the equations for its variable. Now, that might mean that there's still variables in there, but we need one variable on the left-hand side and everything else on the other side. We're going to take whatever that equals, and we're going to plug it in to the second equation. And that should give us just one variable in the equation. Once we have one variable, we can find a number for that variable. And once we have the number, we can plug that number back in and find the missing variable. Now, that is all very confusing and everything, but it should make sense as we go, and we'll be in good shape. So, we're given two equations here. 4x plus 3y equals negative 2, and x plus 5y equals negative 9. And what we're going to do is we're going to use the substitution method to find x and y. Now, yesterday we solved for y each time to put it in y equals mx plus b form. Then we graphed it and we found where they crossed. Well, today we want to find x and y without going through the hassle of actually graphing it. So what we're going to do is this. I'm going to look at my first equation. I'm going to look at it and I'm going to say, okay, there's no variable in there that's going to be really easy for me to solve. So I'm going to disregard the first equation. I'm going to look at the second equation. Now, out of this x, this y, this x, and this y, this x looks like it's going to be the easiest to solve for out of all these variables, because all I have to do is just subtract 5y. So that's what I'm going to pick. I'm going to pick this variable to solve for because it's the simplest to solve for. So I'm going to solve for x, and x plus 5y equals negative 9. I'm going to subtract 5y from both sides, and I'm going to get x equals negative 5y minus 9. Now, one more time, I chose x because it was going to be the easiest to solve for. I don't have to divide or multiply. All I have to do is one step, subtract 5y. Now, I used the second equation. Now that I have x by itself, I've used the second equation. I'm going to plug it into the first equation for what x is. I know that x equals negative 5y minus 9. If they really are equal, then I can plug this in for x. So I'm going to say, really, this is, if I want to plug it in this next equation, 4x plus 3y equals negative 2, I know that x really equals negative 5y minus 9. So instead of writing an x in here, I'm going to write negative 5y minus 9 plus 3y equals negative 2. So what happened there was I substituted out the x, and I substituted in the y term. And now I just have one variable. I just have y, so I can solve for y. I need to do a little distributive property, negative 20y minus 36 plus 3y equals negative 2. I need to add my like terms, negative 17y minus 36 equals negative 2. And I need to add 36 to both sides. Negative 17y equals 34. And finally divide both sides by negative 17. I think that y must equal negative 2. So here's what I can do from here. I can plug y into any equation that has a y and an x in it. I can plug it in here. 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 If you're worried about picking the right equation, just always pick the first equation every time. You can always plug it into the first equation. That's fine. Let's plug it into the first equation. Our first equation was 4x plus 3y equals negative 2. I know that y equals negative 2, so I'm going to plug that in. So 4x minus 6 equals negative 2. If I add 6 to both sides, I know 4x equals 4. And if I divide both sides by 4, I know x must equal 1. So my solution would be x equals 1 and y equals negative 2. And I can write that as the point 1, negative 2. Because if I graphed these two lines, I know that they would cross at the point 1, negative 2. So that was a lot to take in for a first example. So again, let's do another one, and we'll see if we can get it to work out. This time, once again, I have two equations, and I have a bunch of variables here. I need to pick the easiest one I can find to solve for. Now, once again, when I say solve for, I want that variable on one side, everything else on the other. I think, once again, this x is probably going to be my easiest to solve for, because all I have to do to solve for it is subtract 3y. So that's what I'm going to do. I'm going to take 3y away from both sides, and now I know what x equals. It's equal to negative 3y plus 3. Now, with this information, and since I've used the second equation, I need to plug it in to the first equation. I'm going to plug in what x is equal to. I'm going to rewrite my equation, 2x plus 5y equals negative 5, and instead of x now, I'm going to put in negative 3y plus 3. So once again, all I did was I just substituted what I know x must be equal to. Equals means interchangeable. They are the same. So now I do a little distributing, and I'm solving for y. I'm going to say negative 6y and 5y is negative y plus 6 equals negative 5, minus 6 from both sides. Negative y equals negative 11. Divide by negative 1 or multiply by negative 1. Y equals 11. If y equals 11, I can now plug in 11 wherever there's an x and y. I can plug it in the first equation. I could plug it in this equation. Anywhere where there's an x and a y, I could plug it in. Okay, if you're confused about which one to do and you just want to get it over with, you can always pick the first equation. It might not be the easiest, but you can always just pick the first equation. I'll pick the first one, just to keep it simple. I'll rewrite my first equation right here. I rewrote that, and now I'm going to put 11 in for y. So 2x plus 55 equals negative 5. I'm going to subtract 55 from both sides. And so 2x equals negative 60, and divide by 2. X must equal negative 30. If I have my two solutions, I can write the coordinate as my answer. Negative 30, 11. That's my solution. So let's just do one more substitution problem. And this time it's going to be a little trickier. This time I need to solve for a variable again. I have this one to choose from, this one to choose from, this one, or this one. Now, I'm going to actually use the first equation this time. I noticed that 3, 3, and 15 all have 3 in common. So I know when I divide, I'm not going to get a fraction. So I'm actually going to pick the first x this time. I'm going to say, okay, 3x plus 3y equals negative 15. So if I want to solve for x, I need to subtract 3y. 3x equals negative 3y plus negative 15, or minus 15, either way. And I'm going to divide by 3 on both sides. So x must equal, once again, you have to divide both parts, negative y. I'm going to say, instead of plus negative 5, I'm just going to say minus 5. So this is my key right here. I need this. I know that x equals negative y plus minus 5. So I used the first equation, so this time I need to plug it into the second equation. Okay, I found x, so I'm going to rewrite my second equation. That's all I'm doing here is just rewriting it. 5x minus 9y equals 3. And now I'm going to take my x, what I know it's equal to, is negative y minus 5. So instead of x right here, I'm going to write in negative y minus 5. And now I just have one variable to solve for. So I'm going to distribute. Minus 9y equals 3. And I'm going to say negative 5y, negative 9y is negative 14y. Minus 25 equals 3. And so if I add 25 to both sides, negative 14y must equal 28. And if I divide by negative 14, y will equal negative 2. So I've got half of my solution now. Like I said before, once I have one, I can plug it into any equation with an x. I could plug it into that equation, that equation. Any equation I want, or this equation. As long as there's an x and a y, I can plug it in. Just to keep things simple, let's just use the first equation again. 3x plus 3y equals negative 15. It's what we started with. I know now that y is negative 2. So I'm going to put negative 2 in for y and solve for x. 3x plus 3 times negative 2 equals negative 15. Do a little simplifying. Add my 6. And divide by 3. X must be negative 3. So my solution is actually the coordinate negative 3, negative 2. And that is my answer.